So we are supposed to construct a triangle whose perimeter is given and the base angles are given. So what we are going to do is we are going to first draw a line segment which measures the whole perimeter of the triangle, in which case all the three sides are within this particular line segment, which is called F here. So this measures all the three sides together, which is nothing but the perimeter of the triangle, which is given in the question. So what we need to do is we need to make a triangle in such a way that part of this segment makes other two sides like this. So M, N and F, all these three parts will become the wanted triangle. So this is what we need to draw now. So how can we draw this? So what we need here is we need to have this line equal to this measurement, and this should be equal to this measurement. So this is what we are working on, right? This is what we need to do. How can we do that? So how can we make a point in this place so that this line is equal to this line and this is equal to this, and we know that these two angles are given, so we can actually turn this side towards this to such an extent that it makes the angle which is given, and this side can be folded to this extent so that this makes the angle that is given. So but it's practically not possible, like you can't do it without construction. So the idea here is this angle is given and this angle is given. So with this angle and from this line segment we need to construct this triangle. Now how can we do this? In order to make two equal lines like this, what we need to do is we can think about how we can make a line like this. So in case if we join these 2 points, say for example like this, and if we make a perpendicular bisector for this, then we can find this point at which you can move this side to this side. So on this line segment you need to find this point. In order to find this point, what you are doing is so for example we do not know this yet. We need to find this point so that from this point we can join this line, and we also do not know this, so we don't have these things in the question. So we have only the line segment, and if we have a line like this and if we can bisect this by perpendicular bisector, and at this point we can make a line in such a way that this line gives you the same as this, so that this is folded towards this, right? At least we just got one part of the triangle. Now the same thing could be done on the other side, which is like we need a line, and if we can bisect it perpendicularly we are getting this point, which means if I draw a line like this, this line will be equal to this line because this is a perpendicular bisector on this. Therefore we are getting the other side of the triangle. Yeah, that was easy, but without having any of this, how will you know how to construct these two lines? What are they? What are the base of these lines? How do you do this? Where do you construct them? What is the angle? How much should you measure this angle, and how much is this angle? So you know that you are constructing from this end point to end point, that's okay, but what is the angle that you need to measure? So for that we need to have a little bit of geometry now. So let's go back and see if we want this. So we have not constructed. If we want this, what should be our angle here? What should be the angle here? How should we construct this line? So what we have here is, this is your isosceles triangle. These two is equal to, therefore this angle is equal to this angle, right? So this plus this angle is equal to this angle because this is exterior angle. So but this angle is given, we know what this angle is, so this angle is given. So if you can construct a line from here such that this plus this is equal to this, so this angle plus this angle is equal to this angle, then we are actually constructing two parallel lines. So which means this is an angular bisector. So this angle is given because we know this, therefore we can construct this angle, and then we can find the angular bisector of this angle, and then we can do the perpendicular bisector, and then where it meets we keep that point. The same thing we can do it on the other side. So we can have a parallel line to this line, so that the point, the angle given here is the angle given in the question. And this makes, when you make the angular bisector and then you make the perpendicular bisector of that, you get your triangle. So we were working backwards. How do we get, what do we have to do in order to get this triangle? So when we started the question, we didn't have anything else other than we didn't have this, we didn't have this, and we didn't have any other triangle. None of these lines were present. So we are going to work backwards and see this is the only thing that we had. So what we are doing is we are going to construct on this line segment which measures the whole perimeter. We are going to construct two lines on either side of the line segment with the given base angles. So we have constructed that. The next thing is we have to find the angular bisectors of each. So we found the angular bisectors, and then we need to find the perpendicular bisectors of that point to the end of the segment, which is perpendicular bisector on this side, which is between this point and this point, perpendicular bisector of this line segment and perpendicular bisector of this line segment. Once we have done, we have got these 2 points which are so we have got the points on the first line segment which are here and here. So we have got these 2 points of the triangle. Actually we have got the base of the triangle now. And then once we got this and we know the point F, we have to just join GF and HF, and you got that. So this is how we construct a triangle given perimeter and 2 base angles, and this is the idea behind this construction. Hope you enjoyed this show. Bye bye.